This video goes along with the optimization problem about the rectangle inscribed in a parabola. And we are at the point where we want to find the value of x that will give the largest rectangle possible. So we need to graph our function, which is area is equal to 18x minus 0.5x cubed. So as we graph this, you want to think about what shape you are expecting. So it's a cubic function, and notice it has a negative leading coefficient. So we expect an S shape. Please always start with zoom standard number 6 so that you go back to a regular window from -10 to 10. And now you can begin to see the curve. You can see the S shape, although we don't see the entire curve. You can see that we're missing the positive peak here, a maximum, as well as the negative here. Now, we really don't need to see the entire S shape because this problem is a word problem, so x represented the base of our rectangle, so a negative value doesn't actually make sense. So we're really only interested in the positive x values here. So remember, you could reset your window just by going to Window. You could go down to Y max and just start choosing, guessing some values. Maybe you chose 20 to see if that was sufficient. But this can be a little cumbersome on a problem where maybe the y value is really large. Like here you can see that 20 was not large enough. So I recommend using your table. Remember, second table. And scroll through your table here. My table started in the negatives. Yours may start somewhere else, but you can just kind of scroll through the table here to see what kind of y values you have. How large are they? And you can see I'm going into 30s and 40s, and then I begin to decrease again. So the largest y value I'm seeing on my table right now is about 40.5. That may not be the largest y value, so we just want to go larger than 40.5. So how about 50? I'll go choose my y max of 50. And now I can see the curve as well as the maximum that I'm interested in. So this is my area curve, and I'm interested in computing this maximum. So above your trace key, it says calc, second calc. We'll choose number 4, maximum. Pay attention to where the cursor is, what I call the bug. You want to have the bug to the left of the maximum we're interested in. And right now mine is, so I can just press enter. No need to move it. And then your calculator asks you for right bound. So now you'd want to arrow to the right of the point you're interested in. Now, if you knew approximately what x value that was, you could actually type in the x value if you wanted to. Otherwise, you can just keep arrowing so that the cursor, the bug, is to the right of the maximum we want, and press enter. And then you can see the arrows where we've chosen this region here for the calculator to calculate the maximum. And there's only one maximum in that region, so you can just press enter. No need to actually pick a guess. And there's our maximum. So x here is the x value in my problem, which is the base of the rectangle. My y value here represents the area of that rectangle. So the value of x that gives the largest area possible is approximately 3.46. If I had asked you for what is the largest area, then your answer would have been 41 point, looks like that would be 41.57 units squared is your largest area.